Hello, I'm Sam Scull from the University of West of England, and this is my e-poster for use of game technology for nano-molecule visualizations, a collaborative piece of work with my colleague Chris Yaws at the Materials Institute over in Nantes. Now, I'm sure quite a few of you kind of saw this one and thought that's a slightly unusual kind of poster, a little bit out of the ordinary of the kind of the other posters that are kind of here at this kind of event. I would say though that I have got a theoretical physics kind of background. I've worked in various kind of RA posts doing different kind of simulations of computer simulations of different kind of physical systems before then going to work for a couple of years in the games industry for a studio called Rare, part of Microsoft Game Studios, before then moving back into academia where I've worked in a number of kind of serious games kind of roles, and I'm currently a senior lecturer in games technology at the University of West of England. I'm program leader for our MSc in commercial games development. Now, obviously, games are quite complex visualizations of large kind of data sets. They can be perceived to be that, as well as actually real-time kind of simulations, which we also allow the general public in to kind of fiddle with. And I've produced a number of pieces of work that kind of link elements from animation and computer games to kind of research kind of simulations. And the piece of work that was led to my work with Chris was this one here on visualizing software as a particle system. Now, my colleague Neil Walkinshaw, now at the University of Sheffield, had this system which could extract metrics to kind of measure how pieces of software kind of worked. I wanted to be able to kind of display these in a highly customizable kind of fashion to allow software engineers to kind of get some kind of more general overview of kind of large pieces of kind of software. So what we did was that we borrowed some concepts from games developments, namely the kind of the asset pipeline, to allow the kind of the processing of this information to produce a kind of highly customizable visualizations of these kind of data sets, along with multiple kind of control systems based around different types of control systems that you see kind of in games. Essentially, the asset pipeline takes the artist's input, processes that through some kind of intermediate kind of structure to produce the final software objects, which are then actually viewed in the kind of the game. And almost all games are a very data-driven process to push everything as much as possible into that to allow rapid redevelopment of the game software. Then a colleague of mine, then Chris, came along and said, well, I'd like to see this kind of visualization for the kind of the nanomolecules that I also kind of work on. Because we built the system around this pipeline kind of process, that meant that all we had to do was basically generate another parser that would load in Chris's XYZ files of his molecules, and it would drop them into the same visualization and allow all of that to automatically work for his molecules as well as for the data sets for the software visualization, including things such as VR. So we have here a picture of one of Chris's kind of PhD students grinning his head off because he's literally flying down the length of the nanomolecule, the kind of nanotube that is the subject of his kind of his PhD. This was all kind of using kind of low-level kind of software because we wanted to have very large data sets for the original software kind of visualization. But increasingly, even kind of major game studios are using so-called third-party or kind of off-the-shelf kind of game engines. The two biggest known ones are kind of Unity and Unreal. And increasingly, these are allowing customization of this pipeline system to allow much more rapid kind of use of more unusual kind of data sets, which is why myself and one of my master's students were able to make use of this thing here. This is the Looking Glass 3D kind of screen, which interestingly was released not with low-level software, but with a plugin for these game engines to allow it for rapid use. And what we were able to do, thanks to a short-term scientific mission with the multi-comp cost action, was to travel over and spend a couple of weeks producing a couple of data visualizations of, you can see here, nanomolecules as well. And this one here is of atomic force microscopy kind of data in 3 dimensions that can be accessed with the kind of leap motion kind of device. Basically, this asset pipeline concept from games is a very useful method for producing highly customizable kind of implementations of simulations, or in this case, kind of visualization kind of pipelines. Although there is quite a bit of kind of very heavy upfront kind of development kind of costs. And use of games technology for input devices and display devices and interactivity is a highly effective way of doing data visualization, which can be navigated in a very intuitive manner for the kind of the modern kind of audience. Very useful for outreach and kind of scientific communication work. Even more excitingly is modern game engines are increasingly becoming much more accessible and allowing the production of highly detailed data visualizations using a range of kind of modern graphical kind of effects kind of options. Much of the work for these visualizations were completed by students on the MSc Commercial Games Development at UWE Bristol for their Games Research and Development kind of module, and thanks to the multi-comp cost action for funding a number of short-term scientific missions, without which this work would not have been possible. Thank you very much.